Alright, today we're going to go ahead and go over the axial calculations. Very simple x-ray to actually analyze. Not complicated at all, just like the frontal, but very, very important to be able to do correctly. Obviously, in order to get this x-ray, we had to look at the sagittal x-ray and giving us the axial angle. Again, we'll just show that to you real quick. Going along this angle, it allows us to know exactly how to get this x-ray to come to this. Okay. So again, first thing that we want to do is obviously make sure that this is positioned correctly. So I'm going to zoom in and bring it down just a little bit and zoom in all the way. Obviously I want the bone enhancement to be up to 80, so it's a little bit clearer, and make sure that I can see my surfaces just fine. Okay. Now what I want to do is I want to go to the AO main calculations, place this down. You can get that a couple different ways. You can either go to the toolbox and go to the AO main calculations right here, or again, easier to just go to the Calc AO on the left hand side. After that, we want to click on the AO Axial Circle Finder, which is that capital A. For this, you want to zoom in as much as you possibly can. You want to find the lateralmost aspects of the axis. So place a dot there, go 1/4 inch in, and all the way out to the edge. Now to make sure I actually place those in the right places, I always measure. So again, going to the top, measuring out. See how I didn't go all the way? Well, it's a good thing I did this. Coming out to that lateral edge, coming up to the very top. Now we know where that 1/4 inch is, and I need to place my dots accordingly. So highlight this, bring it in to where it's up on top there, and same thing on this side. At that point I can delete these two references, as now I know that they are at least distance how they should be. However, they're not in the correct location, because they need to actually be just barely touching that surface. So this one can come down just a little bit, so that angle is now, or that corner is now touching that surface. And this can come down to right there, and come on this side. That's touching there great. This is touching just fine. So now if I zoom out, I can see that my angle is, or my actual surface is a 5.9 inch diameter circle. At that point, I'm going to come in, that just gives me a little reference. Now I'm going to come in with this AO Axial Circle template. So it's the A with that little bit of a triangle, left click, bring it over here, left click again to put down the template. I right click to make sure I'm getting off the template, and then I highlight it again to make sure I can manipulate it. So now we know that we want to look at the roughly around the 6 circle, because that's what the automatic calculations figured. And how this is read is actually a little bit complicated, so let me just teach you that real quick. The 2 bold semicircle right here, that's for the 2, okay? The next one in is not bolded, and that's a 2.5. 3, 3.5, 4. So even though the 4 looks like it would be this one, it's actually the one above it. So 4.5, 5 would be this bold one, and so forth. Okay. So we already know that we want to be at the 6, so that would be the bolded 6 right here. So I'll bring this down. The first thing we do is we don't want to superimpose on the buttons as much as possible. However, sometimes it's not always possible to do that. So the first thing we want to look at is lining up the outside edges first. So once those 2 are lined up, then I try and line up the 2 next ones and see if it's possible. It is pretty darn close. This superimposes just a little bit, but overall not too bad. We want to get, again, as close as possible. If it was pretty dramatic, like let's say this one's way down here for some strange reason, how I would measure that is, again, line up the 2 outermost and then line up the top one, or that middle one right there, and remembering, okay, that was at a 6. Now to try and do the same thing, but disregarding this dot and instead now going with this other one, I would have to come way, way down, bring the template closer to, almost a 12. It was almost way exaggerated. And my video program's going a little bit laggy, I apologize. But it kind of gets the point across. That is at a 12, or no, I guess that's 11, because again, we're going up like that, so 9, 9.5, 10, 11 right here. 11 is still on the outermost edges right there, and touching the top now. So you would add 11 plus the 6, and then divide it by 2. That would give you the rough estimate of that particular circle. Obviously, that's not for this circle, that's just for the practice. But in any case, it would be 17 divided by 2. So 8.5. Let's go ahead and erase this template, though, because we want to make sure that this is back up where it should be. Now let's go ahead and put that template back down. Alright, it's highlighted. We already know it was at a 6. We press the question mark or the /, and it says enter discover value. That's where we're going to place the 6, and then click OK. At that point, you can zoom back out, scroll up, and now we have an axial circle of 6. Again, referencing it's now 6 inches of a diameter. And that's all you have to do for the axial x-ray. Some nice things to be able to know is you can cross-reference very well between the axial and the frontal. We'll probably cover that a little bit more later, but the only way that you're able to do that, though, is making sure that there's no rotation in the axial x-ray itself. But if there's no rotation, then you can definitely use it. So one thing to look for is the width of the bodies down here. Also, one of the things we want to look at is the spinous process. So it's very clear to see it here on the APOM, not always so easy to see it on the frontal. Well, that concludes this video. Again, very simple, just to know exactly how to do the axial analysis.